Hello again! Welcome back. So today we're going to talk about chapter 16, which is the lymphatic system and the immune system. We kind of shoved the immune system in here because it houses itself in the lymphatic system. It's like if the immune system is like the Super Friends, then it's like, or the Justice League. Sorry, I'm nerding out here. This is the Hall of Justice where they all hang out together to respond to, emergencies in the body. So the lymphatic system is kind of where they hang out. It also is the place where basically, as I was mentioning in the last lecture, fluids kind of escape. So we need to kind of get them back in, or they actually can do damage if they're allowed to, hang out and stagnate in your body. Remember, we don't want things stagnating in our body. That leads to bad things. So, the lymphatic system is a partner to the cardiovascular system in that it assists in circulating fluids around the body, mostly to get rid of wastes and toxins. It can also be paired with the immune system, as many of the cells in the lymphatic system give rise to ones that act as defense against diseases. So we're going to talk about the lymphatic system in like the first half of this chapter, and then we're going to talk about we're going to turn right around and talk about the immune system in the second half of this chapter. That's kind of how I split this chapter. So anyway, transports clean fluids back to the blood. It drains excess fluids from tissues that, maybe hanging out in an area that shouldn't be, removes debris from cells of the body, and transports fats from the digestive system. So he wears a lot of hats. He wears a lot of hats, this guy. So the lymphatic pathways transport excess fluid away from interstitial spaces, or else they'll just swell up. And if you've ever been pregnant, you might have had this happen to you. I know my ankles swelled up a couple of times about this. So we've got to kind of bring a lot of this escaped liquid back to the circulatory system. So that's where we got the lymphatic capillaries, which joins with the blood capillaries. So if there's a blood capillary, you'll see a lymphatic capillary that's kind of like all twisted around in it. So that way it's kind of like, sucking up interstitial fluid that might be trying to escape during that whole gas exchange part we were talking about. See how the water went out and water went in? Yeah, not all the water want to go back in. So that's where the lymph system comes in. So he has one layer endothelium, and he has little flaps to pull in the lymph. The lymphatic vessels are similar to veins, but thinner. They're only made up of 3 layers. And they do have valves, just like the veins, to prevent backflow. That leads into the lymph nodes, and the lymph nodes are like airport security. If your body was a airport, lymph nodes would be airport security, and they're way more invasive than our airport security. Way more invasive. So that's what the lymph nodes. We'll talk more about them in a minute, but they're kind of like checkpoints all over your body where the lymph basically goes through, and there's a whole bunch of white blood cells hanging out going, everything looks good, everything looks good, everything looks good. Uh-oh, there's a virus, eat it. So we'll talk more about them in a minute. And the lymphatic trunks. So this drains the lymph from the lymphatic vessels into one or 2 major collecting ducts. So again, as you can see right here in this awfully fuzzy picture, sorry about that, not entirely sure why it's so fuzzy. There's a better picture later, but this is right here lymph, and you can see it's single-celled, and the tissue fluid, that like if there's excess, it's literally just pulled right in. Think of it like kind of a vacuuming effect. And when it enters, that fluid enters, it literally becomes lymph. It's almost the same as it was out here, but it just gets a new name because now that liquid is inside the lymphatic system, and therefore it is called lymph. So, again, you got openings right here where we basically, get the fluids coming in. We've got these anchoring filaments, so these things aren't just flapping around. So anyway, and there you go. So that's what, a lymphatic capillary looks like on the inside. And these, like I said, are intertwined, usually like roots in the capillary beds. So these guys are not separated in any form or fashion. So I know it looks like kind of like a freaking one of those musical forks you hit and go ding. They don't look like that. They're actually all wiggly up inside the capillary bed, twisted all around, kind of like roots growing in the capillary bed. So again, excesses that aren't going back in get sucked up here, and they go through, and you can see these veins for backwashing, and it goes into a lymph node for checking, and then it goes and collects in bigger, and then dumps back into into a vein, and then brings that, which puts it back in the circulatory system. So, sorry again, Monty, I'm sorry. So the lymph gets collected, about 3 liters of it. So yeah, we're constantly moving it around and put back into the veins. And we have 2 major collecting ducts. We've got the thoracic duct, which is wider and longer, and dumps into our left subclavian vein. Congratulations. You now need to know a vein. The right lymphatic duct dumps into the right subclavian vein. So one's way bigger, the thoracic duct right here, than the right. And that's because this is one of the weird ways the body's kind of like divvies itself up. It's just kind of weird, because this purple area is drained by the right lymphatic duct, but the rest of the body is drained by the left. How this division came about in your lymph system, I don't know. I mean, there might be, hopefully there's somebody way smarter than me that could explain this, but I am not that person, and I apologize for that, because it's like, why this small area for one, and then the left gets the rest of the body? It just seems like not very smart, delegation of responsibilities here. I'm just saying. Just something weird I wanted to point out. So that's why the right lymphatic duct is actually way smaller than the left, is because the left is dealing with a whole lot more of the lymph coming in for the rest of the body than the right is. Why? Got me. Anyway, so often during the exchange, capillaries, you lose some plasma. If it doesn't get removed, it can do some major damage. We'll talk about that later. So the movement, it gets pushed into the lymphatic system. It becomes lymph. So basically, lymph is plasma under another name. And if we don't funnel it away, as I was saying, it basically can cause swelling in places called an edema, which is an accumulation of an excess of tissue fluid. Trust me, if you ever want to know about how annoying edema is, just ask a pregnant woman about it, because I assure you, it is so irritating at parts of your body, because you're basically growing a whole new human being. And your lymph is all over the place, and your plasma is all over the place. And unfortunately, we're making a lot because we're also making a new human, and because of that, you get lymph in places you didn't need, and swollen ankles. It's not so fun. Hard to walk around. Gosh, who came up with this system? Anyway, Monty, I think you've got it better with the egg thing. And it's funny, because his species, when they hatch out of eggs, they actually stick their head out after they hatch, look around, and go, and then they go right back in their egg. Actually takes them a few weeks to finally come out of their egg. So literally coming out of your shell. Yeah, ball pythons are goofballs like that, aren't ya? He's like, I guess. Anyway. So, aside from, moving fluid, lymphatic system also is where the immune system basically works. And they have several checkpoints where the lymph gets screened, like airport security, except way angrier. And those are the lymph nodes. And MALTs, or mucosa-associated lymphoid tissue. And these are some things that you probably didn't think had a job in your body. Your MALTs include your tonsils, which, you're like, but don't we get those removed? Yeah, only if they're obstructing you breathing as a child. Or they've swollen up and becoming, absolutely, gotten to the point where they've swollen up so bad that it's cut off your airway. The appendix, if you were under the impression the appendix does nothing, no, it's actually part of the lymphatic system. It actually houses a lot of good bacteria that we need to replace if we lose some in our gut and whatnot. The appendix is a house for that. However, bad bacteria gets in it. That's when your appendix ruptures, and you could die from that. I actually had that happen to my first ever college roommate. And keep in mind, this was back in 1998. I was a dumb college freshman. I did not have a car. I did not have a driver's license. She did, actually. She had a car. I was one of the rare, my family just couldn't afford it. And I understood that, so it wasn't like, it was a bummer, but I just, it was a hot mess. Anyway, and then she got sick with the flu, and I just thought it was a flu. I mean, I wasn't a doctor. I was a stupid college freshman. And she got really sick. And her boyfriend came and said, yeah, we better get her to the hospital. And I go, yeah, that makes sense. You probably should. So he drove her to the hospital. Come to find out, it was appendicitis. She had to go get her appendix removed because it had gotten infected. And so, yeah, it was insane because then her family came back to get her stuff out of our room and they yelled at me. And I'm like, I'm sorry? They're like, why didn't you do more for our daughter? And I'm like what? And they're just like, well, you're her roommate. You're living with her. You should have known something was up. And I'm like, I'm not a doctor. It looked like a flu. Her boyfriend was attending to her. And what did you want me to do? Call 911? I can't diagnose people. Even today, I can't diagnose people. I teach anatomy and physiology. I'm not a doctor. I didn't stay at a Holiday Inn last night. So it's just, it was insane. It was crazy. I know they were just upset that they were looking to, they were looking for, but I don't know what I could have done. I still look back to it to this day going, is there anything more I could have done? One of those moments. Anyway, so yeah, tonsils, appendix, and the Peyer's patches, which are on your intestines. So we do have the tests for down there, just in case we eat something and it wasn't destroyed by the stomach acid, which happens. Looking at you, Arby's. Anyway. So yeah, we actually do remove some of these, but they actually do have jobs in your lymph system. That doesn't mean you can live without them, but it's better you live with them. Like I said, I still have my tonsils. I still have my appendix. My brother, on the other hand, he was born, his tonsils and adenoids were so huge that he couldn't breathe, and he would gasp all night long, and it was freaking my mom out, and she was like, she didn't know, because I was such a healthy, wacky baby. So number two, he was just not, so she finally went to the doctor, and they had to have his adenoids and tonsils removed pronto so he could actually breathe as a baby. He was a very, very drooly baby because of this. Drooly. All right, so let's talk about lymph nodes. So these things are like actually about the size of a tiny bean. Like if I pulled a lymph node out of you magically without hurting you, it would literally be the size of the top part of your finger, from this crease up to the tip. They're not big. They are not big. But they're packed full of insanity. So again, you've got the cortex, and then you've got the medulla right here. You've got basically a whole bunch of things. There's a germinal center and a follicle right here. So you've got a whole bunch of afferent lymphatic vessels coming in. So more than one coming in. And then usually out of the hilus, which is this, because it looks like a tiny bean. You've got two efferent lymphatic vessels traveling out. So for every, bunch that's coming in, you've got only two going out. And again, so that's the hilus, where the curve of the bean is. Anyway, and these follicles right here. And this is where all the white blood cells like to hang out, checking everything that's flowing through, see what's going on, gobble it up if it's not supposed to be there. So now, another couple of organs that are important to the lymphatic system is your thymus and your spleen. Your thymus, which actually shrinks as you age, which is insane to think about because it actually has a major job. And he is right behind your sternum. And is a nursery for your T lymphocytes and our T cells. And they come from progenitor cells in the bone marrow, then develop in the thymus, mature, and then they're released from our thymus to do their job. The spleen is like a large lymph node, and it's made up of two tissues in the lobules, white pulp and red pulp. White pulp is filled with lymphocytes, so that's where all your white blood cells are hanging out, and red pulp is filled with red blood cells, lymphocytes, and macrophages. So the lymph nodes filter the lymph, the spleen filters your blood. So therefore, if you've got red blood cells that are ailing and not doing their job, this is where they go to get recycled. Aside also with the liver and the kidneys to an extent. So another red blood cell recycling area, but it's also basically to filter your blood for the. It's like the major airport security for your blood, your circulatory system. So it's looking for things that might be floating around in your circulatory system that should not be there. So that's what your spleen does for you. So the big circulatory system, airport security. That's actually pretty rough. So again, the spleen. Again, it's bean-shaped. The white pulp's usually in the middle, red pulp's surrounding it. You got your vein in your artery coming out of the hilum, which is that curve in the gastric surface. Anyway, so there you go. All right. So, again, he does a good job here of going over the lymphatic system. So if you like listening to Hank, feel free. Oh, I guess we're done with this half. All right, so there you go. So that's the first half of our of chapter 16. Yeah, we're on 16. And now the next lecture, we're going to get into how your immune system works, which is actually insanely fascinating. So if I get kind of like giggly about it, it's because I find it really interesting. It's amazing how versatile our immune system is, but it can also be a double-edged sword. And there's a lot of diseases out there, hereditary and acquired, that unfortunately it becomes a double-edged sword. So we'll talk more about that in the next lecture. So thank you for joining me, and I'll see you in the next half. Bye-bye.